want to photograph if you do anything else you leave tonight. And then we are going to explore pig lung tissue and the larynx and trachea, esophagus, heart, gallbladder full of bile, and liver that I have in this nice little white tub for you guys. It's a pluck. It's an entire trachea, esophagus, lungs, liver, gallbladder, and heart, and larynx, and vocal folds, right? And if we can get maybe Scott to blow on the vocal folds, it'll make a oink oink noise.
Wait, how are you gonna spread it out essentially? Like, are you...
I'm just gonna plop it on the table right in front of you.
Whoa.
Whoa, no dude, I'm leaving now.
Let's think about that.
All right, well, let's get to that later. Posterior view of your back, right? Looking at the kidneys, I realize that the right kidney is slightly lower than the left, and that's actually bilaterally equal. Our ribs are there, those are the floating ribs, right? To protect them. And when we look at them in terms of, besides simply using the ribs to protect them, they're surrounded by lots of tissue that we're looking at. So you want to get your bearings first about where I am anatomically. And I realize there's my vertebrae. And then remember what that part's called right there?
Yes. Can we say?
Very good. These are called? Very good. Awesome. Now running along my spinal cord, or spinal column I should say, I have the psoas major muscle groups. And tucked on top of them, I'm going to place my kidneys. But I can't just place them there. I need to kind of pad them and protect them like really expensive china. So we're going to surround them by fat. And since it's a nephrotic structure surrounded by fat, let's call it a perinephritic fat. Because peri simply means around. Right? Like perichondrium, periosteum, right? So I'm going to surround my kidney with fat. Now, there's going to be a really tough fibrous capsule that goes around the kidney to help the kidney maintain its shape. Has anybody here ever actually felt a real animal's kidney? What does it feel like?
It's sort of like one of those plastic water bottles. It's sort of tough and resilient on the
It's a
outside.
plastic water bottle?
I mean, when when it's not completely full, you can squish it a little, but you can't let it crush it in your hand. It's sort of.
I'm thinking more like a sandwich bag full of Jell-O.
That's a good way to say it.
Right?
It's
It's
got
really
some resistance.
wobbly and jiggly, right? And I want to maintain its shape. So we used to be able to, we might have one for you guys later, an actual real unchemically treated kidney. When you guys work with preserved kidneys, you can play racquetball with them, all right? These real kidneys, you could shake it and tear it, all right? Because it's just a really kind of a gelatinous gel-like mass of tissue. So I want to surround it with a fibrous capsule to keep its shape, but then I also want to cover it with another layer of tissue called renal fascia. And together with the perinephritic fat pad and the renal fascia and my fibrous capsule, I get to kind of keep the kidney in shape and keep it kind of plastered up against the psoas major group right by my last two ribs, so I can kind of keep it from moving around too much. This is looking down on top of you, so your head would be up here and your pelvis is more behind the screen. All we did is cut you in half, like right about here, Scott, and look straight down on top. We'll spend more time on this in the digestive section, but if you look at this word I circled for you guys in blue, right? There's this layer of serous membrane called peritoneum. It's your abdominal version of pleura, your abdominal version of pericardial tissue. And it's going to be covering the organs. And in this case, it's actually covering on top of your kidney, which you will reintroduce in the digestive system. But that makes your kidney what's known as retroperitoneal. It's behind the parietal layer. You guys are used to things being always in front of a parietal layer. These guys are going to be behind it. So we get retroperitoneal.
So that means it's outside the peritoneal cavity or something?
And not outside, it's behind it.
Between the parietal perineum
And your muscle tissue.
and your muscle tissue.
So the basic analogy is, you hire me to be your architect, not your architect, your your designer. And I come in and you have all these nice paintings on the wall, and I selected for you very nice wallpaper, and I wallpaper your walls, but I forgot to remove the paintings. The paintings are retro wallpaper, but in other words, they're retroperitoneal, and your kidneys are behind the wallpaper, in a sense. That also helps to keep them in place.
Why is that the parietal peritoneum when it's up against an organ? Why isn't that visceral?
Because the parietal, because this is your abdominal cavity. This is actually lining your abdominal cavity, but in this case, it actually also covers the organs. So it creates we'll get to it in digestive, right? Just remember that it's retroperitoneal, actually behind the parietal layer. And everything else is usually in front of it. Here's a cross section of our kidney. What's nice is you guys have that need to know list, and there's lots of pages to it. Because most of the pages are diagrams, and you have one of these in your diagram. It has no names on it. That wouldn't be any fun, right? It's simply for you to match the picture with the book, right? Learning how, well, this must be that must be this, right? And you've got also all these kidney models that are over here. Various different kidney models to look at and to play with. This looks an awful lot like the diagram, so you can get the models next to the diagrams that are labeled and unlabeled. But it's nice we have learning the various parts of our kidney. First thing to notice is like your adrenal gland. I have a cortex and a medulla. The cortex is simply the core. Not the wrong way to put that. The outer layer of all of this. All of this is the cortex. And then from here on down to the base of these pink triangular shaped things, that's the medulla zone, right? So all of this is medullary zone. And in the medulla zone, I have these pink things known as renal pyramids, because they're kind of shaped like a pyramid. But it's a three-dimensional thing. It isn't just a flat, two-dimensional image. So this model actually is a very good idea of what the pyramids look like, and to me it reminds me of a nice little ice cream cone. Right? It's a three-dimensional funnel-shaped structure. It's wider at the top and kind of narrows and tapers down. And all of these are those things. All those pyramids are shaped like this funnel-shaped pyramidal design organ. And when we look at that renal pyramid, the part closer to the middle of our kidney, right? This part's toward the middle are known as the renal papilla. So there's the papilla of the renal pyramid, papilla, papilla, papilla. And if I take a single renal pyramid and the cortex found right above it, kind of like someone's house and property lines, the tissue between the renal pyramids, right, are known as columns, renal columns, these guys, right? That's the tissue between the pyramids. This renal pyramid says, well, I'm going to own half of that renal column, all the cortex above me, and half of the column on my other side. And this dotted line is my property line. Well, that dotted line represents a renal lobe, the functional unit of a kidney. And it's full of lots and lots of little nephrons.
So the renal papilla, that's the tip, essentially?
It's the base,
of
like the apex of the heart.
Okay.
Right? It's like the apex of my renal pyramid.
Okay.
Now, if I look at this, I go up to maybe to this renal pyramid, and I can see the papilla. I realize the papilla seems to be kind of protruding into this little column area. Well, that little column area is called the minor calyx, or calyx. So that's a minor, that's a minor, that's a minor, there's a minor, 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 minor. And I realize that when minors kind of merge into a bigger area, let's call those the majors. So there's a major calyx and a minor. Another major right here. When the majors merge together, we form then the renal pelvis. It's where all my majors come together. So what I think about it is this is a three-dimensional structure. So I've got, this is actually a tube, right? Coming down like, and there's probably other tubes coming this way to join the top of this major calyx. And there's other majors coming in as well, forming this big, hollow, empty atrium-like chamber that leads to the renal pelvis. The renal pelvis then leads into the ureter, not urethra. Some people want to call it urethra, so make sure you kind of practice that difference. Now there is spaces between my calyces, both majors and minors, and we call that a renal sinus. It's just an empty cavity But nature doesn't like empty cavities. That means things could be squished, so we tend to fill them up with fat. So usually your sinuses are full of adipose tissue. And all this you can find on that model. And some of our other models as well. All right, your favorite topic. You got more blood vessels. You thought you were done with blood vessels, didn't you? Well, we've got more to go. And in the digestive system, we have even more to do. You're going to know lots of already when I'm done. All right. Renal artery brings blood into the kidney. The renal vein probably drains the blood from the kidney. That's really cool. So here comes my renal artery. The rule is when things branch, I tend to change the name. So the renal, which you only have one of in each kidney, then becomes into segments. Those called the segmental artery. And all of this is segmental. All of these are segmental. The segmentals, once they get in between the columns or the lobes of my renal structures, are then referred to as interlobar arteries. Right, the segmentals go in between the lobes. They're now called interlobars. I have a flow chart for you guys to follow with this as well. Right, that'll be this thing right here that we'll get to in a moment. So the renal artery becomes segmentals. Segmentals become interlobars. Then they're going to kind of go over the top of my renal pyramid in an arc-like fashion. So these guys are known as the arcuate arteries. Right? These little arching shaped things. Those are all arcuates. Now I know this is the cortex in here. And I can see how these little red lines are radiating out into the cortex. So they're called cortical radiate arteries. Because they're coming off of the arcuate and they radiate into the cortex. That might be the safe name for you guys to remember. I forgot if it's McKinley or Martini or exactly who it is. Kitty, move. Taking my kitties home tonight, so I can hang them outside my door. Since it's going to be Halloween. I'm going to take those to my door and hang them outside my front door. I'm going to take the kitties and put a big bowl of candy between the front limbs and see who's brave enough to reach for the candy. Man, I can take advantage of being an anatomy instructor. All these cool things for Halloween, right? Actual guts hanging by my door. It'd be so cool. All right, I digress. What's the name of the artery that comes off of the segmentals? Right, the interlobars. Then I get the arcuates, right? What's called the cortical radiate arteries. But they have another name, a frustrating name. They're called interlobulars. Right? Interlobu. There's the difference. Interlobular. Do not get interlobulars mixed up with interlobars. The best way is to avoid it. So they call them cortical radiates. But do be aware that some books will use this term and not cortical radiates. And some will use cortical radiates and not this term.
Which one do you want us to use?
Whichever one you want.
Oh, we can use that one?
Whichever one you don't get confused with. Okay. Now let's zoom in on this. So there's my interlobars, right? There's my arcuate. There's my interlobulars, otherwise known as my cortical radiates. And what I see in my mind is a red plant with stems and flower buds on the ends of the stems. Well, the plant is the cortical radiate. The stems that lead to the buds are the afferent arterioles. And the buds are the glomeruluses, the little round things right there. So I've got lots of glomeruluses along the length of the cortical radiates. I have lots of afferents coming off of the cortical radiates. Let's zoom in on the path. And I always tell you guys to learn intellectually. And then you can find them on a diagram because you know the route. So this just simply says what we've been showing you all along. Renals become segmentals, which become interlobars, which become arcuates, which become cortical radiates, otherwise known as interlobulars, which become afferent arterioles, and here was tonight's lecture, right? blood comes in through the afferent arteriole. We filtered it through the glomerulus, right? And then we talked about how the blood will leave the glomerulus through the afferent arteriole, which becomes those peritubulars where we do all of our reabsorption with and our secretions with. That will lead to venules, then the cortical radiate, arcuate, interlobar, and then the renal veins. You definitely have to know the artery pathway all the way down to the peritubulars. From there, just simply say we're going to end up in the renal vein eventually. But it's really not hard to remember what's what. Another way of looking at it, right, is I can realize that this part is the cortex. This is the medulla of my kidney. I can see the arcuate artery that traces the border between the medulla and the cortex. There's my cortical radiate artery. There's my afferent, my glomerulus, and there's my efferent. And this is your first opportunity for an anatomically accurate diagram of the nephron. Pay close attention to how you have the afferent here, the little teeny efferent, and then this tube right there passing literally between those two arterioles. Literally between them. Pushed up against them. No room to move, pushed up against them. Some other diagrams will let us see that in a different way, but it's not anatomically accurate.
Which tube are you talking about that's between them?
That tube right there, which we're going to name in a second, okay? So let's look at the name of that in a minute. So this kind of beige colored snake looking like thing, right, is a nephron. This part right here, right behind the glomerulus, as we saw in lecture tonight, was the proximal convoluted tubule. Convoluted means what?
It's all tangled up.
The what?
Like sort of tangled up and goes in every which way.
So if someone says you have convoluted thinking, what are we saying?
You're all tangled up.
You're all going different directions, right? Well, that tube is all tangled up, right? And it's a really tangled up tube next to the glomerulus. Hence proximal convoluted tubule. And then it straightens out, right, to become the loop of Henle that we talked about, right? Where you have your thick descending, your thin descending, your thin ascending, and your thick ascending. Then it becomes convoluted again, but it's the furthest part of my tube. So we're going to call this the distal convoluted tubule, which is the name of the tube you guys were just asking about. That is your DCT, right next to the afferent and efferent. We have more diagrams to literally show that, but it's a little easier to get in your head. My point is that this is your first anatomically accurate diagram of an nephron structure, showing the distal convoluted tubule between the afferent and efferent. We'll come back to that. This is a schematic diagram of the region, not anatomically accurate, because there's your distal convoluted tubule and there's your afferent efferent. That purple thing right there is to remind you that this is actually way over there. So it's literally, you actually take this and just fold it around like this. So it comes up between these two. But as we saw in lecture tonight, right, my nephron is comprised, well, what are the two major regions of a nephron? Based upon this slide, what are the two major regions? Let's work on getting information from a diagram. Well, I can see a bracket, like a family tree. So apparently the two major regions are the renal corpuscle and the renal tubes. What part's the renal corpuscle? Well, apparently just this part called the glomerulus. The renal tubule is comprised of the purple, the pinkish red, and the greenish. In other words, the proximal convoluted tubule, which is this part here, color-coded, the nephron loop, and then my distal convoluted tubule right here. That's all part of the renal tubule. There's the afferent arteriole, becoming the glomerulus capillary, and then there's the efferent leaving it, and coming between the afferent and efferent, coming up out at you just like this. This is going to be that distal convoluted tubule. A part of this that literally is looped back over here, which is what this is trying to show you. All right, see how it's actually looped? It's not a straight line. It comes back and it folds back on itself and pops up between those two. Then it becomes connected to this thing called the collecting duct. But to connect the distal convoluted tubule, because it is color-coded for you, right, to the collecting duct is a small portion called the collecting tubule. It's more than just one cell wide, but it's this last little part of the distal convoluted tubule that plugs into the collecting duct. So I look at this picture and I go, okay, wait, I can go from here to here, go back a step, then I realize that if that is my distal convoluted tubule, then this part right here is probably the collecting tubule of that distal convoluted tubule, which means that's probably a collecting tubule to another nephron, and another collecting tubule to another nephron, another nephron, another nephron, another nephron. There's actually lots of nephrons that feed into a common collecting duct. Think of it as the major sewer pipe in an apartment complex, right? And all the other apartments are contributing their sewage to that one major pipe. When you look at the other diagram, now this also is anatomically accurate because I realize there's my proximal convoluted tubule, then the descending thick, descending thin, a little tiny ascending thin, a long, over-exaggerated ascending thick, then my distal convoluted tubule to my collecting tubule to my collecting duct. Collecting ducts, when you bring a couple of collecting ducts together, we form what's called the papillary duct. The papillary duct leads to the renal papilla. So this renal papilla area here has papillary ducts. And don't forget that the renal papilla was that part right there. So in your mind, all these papillary ducts are coming to the end, and there are holes. We can kind of see it right here, if I notice this. See that little hole right there? That little pore opening? That means you're just dripping, dripping, dripping. That means when you look at this in your mind, you're just dripping urine. It drips into the minor, it drains into the major, which drains into the pelvis, which drains into the ureter, and goes into your bladder. Right? There's no sphincter. This is just leaving a faucet on drip for all of your life. Just drip, drip, drip. Yeah, Scott?
So, is the cortical nephron at the top of the pyramid?
No. Not exactly. There's the cortex, right? There's the medulla. And the medulla is where I can find my renal pyramid, right? But the renal corpuscle, the glomerulus, right, of the nephron is really high up in the cortex. So we call that a cortical nephron. Its loop barely goes into the medulla. However, these guys, right, what does juxta refer to? Like next to, right? Juxtaposed. So apparently this nephron is right next to the medulla. So it's called a juxtamedullary nephron. Its glomerulus is really close to the border of the cortex and the medulla. And notice the loops, right? The loops barely go into the medulla. But these guys, they go all the way, almost down to the papilla. When you have really, really long loops, you can do a lot of water reabsorption. This is what you use to make really concentrated urine. Only 15% of your nephrons are actually juxtamedullary nephrons. Only 15%. Therefore, how many are corticals? Now we're back to math again. I think we do math. What's 100 minus 15? 85%. So 85% of your nephrons are actually corticals.
Does that, the juxtamedullary nephron, is that like a similar structure to the other one? With like,
Oh yeah, same parts,
It's the
but
same
but what's
parts.
different? What do you notice in the picture that's different? All the parts are there, but what's different?
well, the loop is really.
It's a lot longer, exactly, right? Plus their placement in the
It's next
overall
to the
structure.
medulla.
So if I go back to this, to talk about what Scott was trying to think about, my glomerulus of the corticals are up here. The glomerulus of the juxtamedullaries are here. The nephrons of the corticals probably go to about here. And then the nephron loops of the juxtamedullaries go all the way down here and back up again.
Oh,
It kind of shows it on slide 5.
Mm-hmm. He does a little bit.
That one.
Right there, right? A little bit of a loop right there, right? And all the way down to there. So you can see the papillary duct right there and some other adjoining collecting ducks.
I have a question.
What?
Do they both have the loop of Henley, or just one of them have it? Or can they
No? What's that right there?
loop of Henley?
What's this?
Same?
Yep. So they both have it.
Same structure.
Yep. They have the same structures, just one's longer than the other.
Okay.
Off topic. Are we gonna talk about kitty cells there?
Nah, a little bit maybe.
That's curious.
All right. Let's talk about those places where the reabsorption goes into. The capillary bed that came from your efferent arteriole, right? Remember, the pathway is efferents become peritubulars. And what does peri mean? It means around. So it's around the tube capillaries. So I gotta find capillaries that go around tubes. Oh, all that red stuff, right? It's all capillaries. And they're all going around the tubes. So all of this is peritubular capillaries. And this is a cortical nephron. Now, the juxtamedullary nephron, yeah, they've got red stuff too. They have peritubulars up here, right? They got something else though. They have the vasa recta, which refers to the long, straight portions. When you have really long portions of the capillary that parallel the tube, right? You have the vasa recta. These guys don't have long portions. Those are short. I need nice, long, parallel strands of capillaries. That's known as the vasa recta. Only the juxtamedullaries have the vasa recta. The corticals do not. They both have peritubulars? Yeah, because the box shows you, right? One for each. Bless you. Gotta teach Kayla to sneeze louder. All right, let's zoom in on this. So now we get to be a little more reminded of the anatomical relationship. There's your afferent arteriole, and then you remember, right? Arterioles only had maybe a single layer of smooth muscle to wrap around them. No tunica externa, very little tunica media. Then becomes the glomerulus capillary ball, and then it exits through the efferent arteriole. And there's a tissue that covers on top of the actual capillary, these little purplish-like cells. And those purplish-like cells are actually known as podocytes, but they create a layer of tissue called the visceral epithelium. The name of the cell is a podocyte, because cyte means cell, and pod means foot, so it's a foot cell.
But
The tissue will then fold on the outside and become the outer capsular epithelium, and together these two layers form the glomerular capsule. Simple squamous on the outside that folds in and become podocytes that cover the capillaries. Then there's your little capsular space. There's the beginning of your proximal convoluted tubule, and here you are looking at the big purple distal convoluted. So this part right here, what they're trying to show you is that part right there, right, where it comes up between the afferent and efferent. When I look at this and I study the epithelium of my distal convoluted tubule, is it the same? Are these the same as those? Are those the same as those?
no.
No, we're different.
What shape would you call those? Very good, and these guys would be cuboidals. You have a segment of the distal convoluted tubule, and this only applies when it's actually between the afferent and efferent. Only this part, between the afferent and efferent. You have columnar epithelial cells of the distal convoluted tubule that are facing the arterioles. We call those cells the macula densas. I just now realized this. Sorry, Tramp should have said something a long time ago. Of course, you wouldn't even say hi to me in Starbucks. Get this out of your wages for a second. Less obstructive, young lady. All right.
Wait, the columnar are the ones only in between the efferent and the afferent?
Yes, right there.
Or the distal, only those ones in the purple?
Yep.
Okay.
That means right down here,
Yeah,
they don't exist.
and then what are they called, you said? Okay, sorry.
It's okay. And our part of what I try to do is hound you guys about just taking time and going slow and looking at the picture, and usually we name everything for you in the pictures. Now, what are these little pink cells called? In other words, next to the glomerulus, and there's cells, so it's a really brilliant name, all right? Next to the glomerulus cells, they're modified smooth muscle cells. And they form this region right along through here. And together, the juxtaglomerular cells and the macula densa cells, what do they form? They form the juxtaglomerular complex. Some books call it an apparatus rather than a complex. And when we call it an apparatus, they tend to abbreviate it as the JGA, right? The juxtaglomerular apparatus. I very rarely see the idea of JGC. So you may just want to get used to the JGA, which is the juxtaglomerular complex. There's a different name for it.
I don't understand when people name things other things. Like, why is it?
I have no idea.
It's so strange.
Okay. Now let's take a look at what that glomerulus is. You guys have 3 different types of capillaries, right? Of course, continuous, fenestrated, and sinusoidal. How could we not forget that? That means it's got lots of pores. And the little turquoise arrows represent the flow of plasma through the pores. But on top of that fenestrated capillary is that podocyte. I think of it as like an alien octopus that's landed on top and wants to wrap its arms around the capillaries. And then it has these little finger-like projections or foot-like projections called pedicles coming off of the arms. So it's wrapping its arms around, and there's little finger-like projections that are called the pedicles. And the space in between 2 neighboring pedicles create these filtration slits. Right? That little space where you can see the collar of the capillary, right? That is the filtration slit. Whereas those are the pedicles coming off of the podocyte. This cell can actually change the width of those filtration slits. It helps to modify how big or how fast stuff can actually come out of the capillary. So podocytes wrap around the capillary. And to help you visualize that, we're going to go to this picture right here. Go 2 slides forward just for a second. It's a cross-section of our glomerulus. So capillary comes out here, maybe it loops around and goes back this way. Right? These little purple triangular shaped things are actually the pedicles, right, of our podocyte. There they are. Right? We did a cross-section of them. Then I can see the filtration slits, the spaces in between them. And I can see how the pores that would lead to the filtration slit is really small compared to an erythrocyte. There's no way that blood should actually get into this capsular space. So this capsular space, right, and then the capsular epithelium, this simple squamous, this layer right here is that layer right there. There's the capsular space, right? And here's where they actually did the cross section, right? The upper capillary, the lower capillary, and then the capillary space below it. That is this right here. Upper capillary, lower, and then there's the capsular wall. An actual photograph of it, in terms of microscopy slides, is this. You guys might recognize it from 241, because there's your simple squamous epithelium forming the outer wall of the capsule. There's the capsular space where the filtrate ends up being put into. These are the nucleuses of the podocytes, so that mass is where my capillary would be. And then an actual microscopy photograph, electron microscopy, you can actually see the arms, little pedicles, and little teeny filtration slits, and some bacteria. All right, a quick review of the epithelium of your nephron. You only have 2 cells to worry about, cuboidal and squamouses. Here's the proximal convoluted tubule, right, comprised of simple cuboidal with lots of microvilli. Remember, the benefit of microvilli is that it increases surface area. The more microvilli, the more surface area. The more surface area, the more diffusion I can do. which is why most of our diffusion takes place in the proximal convoluted tubule to begin with. I go through the proximal doing lots of reabsorption, like 108 liters of water a day, 99% of our organics. Then I get to be about 300 milliosmoles as I get to the thin descending, which we refer to as being simple squamose. Then I come up to the thick ascending, which is cuboidal, but not a whole lot of microvilli. Because I don't do a lot of reabsorption. I do transporting. I do facilitated diffusion of my sodium and chlorides into my tissues and my blood, not a whole lot of other stuff. Come up to the distal convoluted tubule, which is still simple cuboidal. So if you realize it, the distal convoluted tubule, the thick parts of my nephron loop, and my proximals, they're all made of cuboidal cells. The only place you have simple squamose is in the thin parts of the loop. That's it. Everybody else is cuboidal. The only thing to worry about or keep track of is that it's only the proximal that has lots of microvilli. The distals have only a few microvilli. If you remember from tonight's lecture, I said that the proximal does mainly reabsorption and a little secretion. And I said the distal does mainly secretion with a little reabsorption. That's why. It doesn't have a lot of microvilli. So I'm going to be limited just mechanically to be able to absorb all that stuff. Just to drum it in, because it's so important, right? Since we just got done looking at the distal convoluted tubule and the lack of microvilli, again realize that the distal convoluted tubule, when it is found right next to the afferent and efferent arterioles, forms what is called the juxtaglomerular complex, which is comprised of the columnar epithelial cells known as macula densas and the smooth muscle cells known as the juxtaglomerular cells, because they are the cells next to the glomerulus. And then to put it in words, because this must be really, really important, right? It functions to regulate the rate of filtration, which we'll talk about on Monday, and plays a role in monitoring and changing blood pressures. We're going to use two hormones that come from the JGA, EPO and renin, right? Remember what EPO does? You remember where it came from, what two organs? So, here's the kidney part, right? And we haven't gotten to the liver yet. And then the overall path that we'll be looking at as we make our urine is that all that filtrate, right, will end up in the minor calyx, which leads to the major, which leads to the renal pelvis, which leads to the ureters, which will then lead to the bladder with that. Let you visualize it one more time, right? Come up to here, there's my collecting duct, to the papillary ducts perhaps way down here. I put this in only because it actually came from a non-majors anatomy, essential anatomy textbook. But they actually show you the openings of the papillary ducts. Like, why doesn't our book do that? So I stuck it in there just for that one reason. For you guys to realize that in the papillary portion of my renal pyramid, that's where my drip, drip, drip happens. And then we get into my two ureters coming from the left and right kidney. Actually insert on the posterior lower portion of your bladder. Now this is a diagram of the male because they have a slightly more complicated urethra compared to females. For two reasons. One, it's a common pathway for reproduction and urination, but often it has three different names to its regions. When I am in the urethra that just leaves the bladder and passes through the prostate, I am called a prostatic urethra. That same tube will pass through a barrier of muscle and membrane tissue. Now I call that the membranous urethra. This will lead to the actual length and the shaft of the penis, where you have then, what they don't show you on here is the spongy urethra. So we're going to go from the prostatic urethra to the membranous urethra to the spongy urethra. Females only have a urethra. Sorry, gals.
Or less complicated. Just kidding.
Well, in that case, you are.
We're
yes,
way
but
more
in other ways,
complicated.
you'd be way more complicated. Oh, shoot, we're done.
Oh,
That sucks. All right, so here's what I suggest you guys do. Two things. One, take a couple minutes break, get some nice, cool, fresh air. And then glove up. And also take pictures of all the renal models. And now for the renal model photographing session, right, any kidney model, any model that has kidneys, like even those torsos back there, they got kidneys in them, right? Photograph our various kidneys. And then all of the different models that are like this on a board. We've got several different versions of these. Each one shows something different compared to others. So you got these guys, you got the ones down below here, right? Photograph all the different ones so you can practice looking at them and dissecting them. And come on Saturday if you can, so you can practice your renal anatomy. But also, up here, we are going to have, for you, what I'd like you guys to at least do is maybe at least put some gloves on so you can actually hold a lobe of lung in your hands. A, because it's Halloween, and what chance you get to actually hold lungs in your hands, for God's sakes. But also to feel how airy they are. And then you can see the heart, the pericardium, the liver, a gallbladder with bile still in it, a trachea, esophagus, a really long, thick aorta, the diaphragm, the epiglottis, the larynx, the vocal folds, the hyaline cartilage of the larynx, all kinds of really cool things. And then when we're all done, I've got a bucket of oatmeal. We're going to chop the lungs up and the liver. We're going to make a haggis.
Oh.
You have a sheep's stomach too?